students. Today we will study another very interesting phenomenon exhibited by light, and that is refraction. But before we start with, let me bring your attention towards the following activities. You can see a transparent glass tumbler here, and I am having a pencil in my hand. If I place this pencil in this position, we don't find any change in the shape of the pencil. However, if I start pouring water into it, the pencil appears to be bent. Isn't? This is something which you have noticed very often. Now, another activity. Here you can see a toy, right? Now, if I place this toy in the water, the height of the toy appears shorter. Moreover, the part of the body which is under the water seems to be enlarged. Now I have some more examples to give. Here are some more examples. The letters appear raised when viewed through the glass slab. A lemon kept in water in a glass tumbler appears to be bigger than its actual size when viewed from the sides. This can very easily be done. If you are having some water, take some water, and then if you put some lemon into it, then you will see that it appears bigger in size. Try out this activity at home. The bottom of a tank or a pond containing water appears to be raised, or it may appear as shallower. But the question is why? Why do we observe such things in our daily life? This is all because light bends. Light bends, but so far we have studied that light travels in a straight line path, that is rectilinear propagation in a transparent medium. So how come light bends? Students, I read again. Light travels in a straight line path, that is rectilinear propagation, in a transparent medium. So we have to understand between the lines. A transparent medium means that we are talking about rectilinear propagation in a single medium. However, when light travels from one medium to another, that is a pair of medium, then light bends. And this is known as refraction of light. To explain you in a better way, I am having this diagram here. Students, now let us consider a pair of medium. I am having these two medium as air and as glass. Now see, when the light travels from air and it passes through glass, then this is the normal here at the point of incidence. This boundary line is usually known as interface. So basically this is known as air-glass interface. So at interface you can see the bending is happening, and once the light enters in the glass, it again travel in the straight line. So you see that bending is happening towards the normal. However, if we reverse the case situation, that is allow light to travel from glass and let it pass through air, then the light will bend away from the normal. The third case, what will happen if we allow light to fall perpendicular on the interface? On the air glass interface, when the light is allowed to fall along the normal, then no bending will happen. Now, these three cases bring a few questions to my mind. First of all, will the extent of bending, that is the bending that is happening here in this case or in this case, will the extent of bending will be same for different pair of medium, or it will be different? The answer is the extent of bending is different for different pair of medium. The second thing that comes to my mind is how will we decide that whether the light will bend towards the normal or it will be bending away from the normal. So but to answer this, we have to first of all understand that why bending is happening at all. So our question is, why do light bend when it passes or travels from one medium to another medium. Students, when I say from one medium to another medium, I mean to say about transparent medium. So, the answer for this question is that speed of light is different in different medium. That is, when light travels from air to glass, its speed slows down. I mean to say that speed of light in air is greater than the speed of light in glass. Speed of light is maximum in vacuum and its value is 3 into 10 to the power 8 meter per second. Please mind that this is the maximum attainable velocity of light. The speed of light in air is taken approximately to be equal as the speed of light in vacuum. That is, speed of light in air is approximately taken as 3 into 10 to the power 8 meter per second. So for all calculations, we'll take this value only. Third important point is that for a given pair of medium, say air glass or air water or a pair of water glass, the medium in which the speed of light is greater is considered as optically rarer, whereas the medium where the speed of light is lesser is optically denser. Students, we see here the speed of light is greater, so it will be optically rarer, and here the speed of light in glass is lesser, so it is considered as optically denser medium. So I have written here in this box, speed of light in denser medium is less than the speed of light in rarer medium, where here V is the speed of light. So in order to emphasize on optically denser and optically rarer medium, I want to tell you that optical density is different from the mass density. For example, the mass density of kerosene is less than the mass density of water. However, optical density of kerosene is greater than the optical density of water. How will you be able to understand? Now, it will be more clear to you if I explain you. If you consider this diagram, take a container and fill water into it. If I pour some kerosene oil into it, then we'll find that kerosene oil floats on water. We know that a substance float on the water only if its density is less than the density of water. So here, since the kerosene oil floats on the water, it means that its mass density is less than the mass density of water, right? But you consider a pair of medium, that air and kerosene, and allow light to pass through air and enter in kerosene, then we will find that the light will bend towards the normal. Can you see this? Right. So it means that kerosene is optically denser. If the medium is denser, then the light will bend towards the normal. So I'll write it here. Light bends toward the normal when it travels from optically rarer medium to optically denser medium. So here air is rarer and kerosene is denser. So this is the answer to my second question. And vice versa is also true. That is, in case we take light from, we bring light from kerosene and here water we have, then the light ray will bend away from the normal. Can you see this? It is moving away from the normal, right? So here this is denser and this is rarer. So we can jot down this observation in the form of bullet. Light bends away from the normal when it travels from optically denser to rarer medium. Okay. So now we have understood about the phenomena of refraction. Now we are in position to give laws of refraction of light. So to understand, you see, consider two mediums, medium 1 and medium 2. Medium 1 I am taking here as air and medium 2 as glass. I take a ray to fall on the medium 1 and allow it to travel through medium 2 because these two mediums are transparent mediums. So the light will pass through this medium 2 as well. Right? Now let I be the angle of incidence and r, small r here is angle of refraction. Please make a note of it. This is angle of refraction, not the reflection. And this boundary line is generally termed as interface, as I told you earlier. Now see, the first law says the incident ray, the refracted ray and the normal to the interface of the two transparent medium at the point of incidence all lie in the same plane. So it's exactly same as the law of reflection. The incident ray, the refracted ray and the normal, all these three lie in the same plane. The second law, which is also known as Snell's law, the ratio of sine of angle of incidence to the ratio of sine of angle of refraction is constant for a given color and for a given pair of medium. That is sine, sin sine, I upon sine r is constant, and this constant is known as refractive index. This gives us valuable information. This expression is known as Snell's law. Students, please make a note of it that this constant, that is refractive index, is a constant value for a given color and for a given pair of medium. That is, if we try out an experiment with different color light, then the refractive index value will be different. Suppose if we take red color, the value will be different from that of green color. Similarly, if we change the interfaces, instead of taking air and glass, if we take air and water or water and glass, even then the refractive index value will be different. So, we'll study more about refractive index in our next video. Thank you so much.